Today we started the second chapter. That is business statistic organizing and presenting data. That is the area we have to cover today. Organizing and presenting the data. Right. What does it mean? So organizing and presenting data mean what? So when you look at this picture, we can realize here you can see the numbers. These numbers represent the data. When we look at this data, it's very hard to understand what the meaning of this data. We couldn't find this data useful for decision making. So this data has to be present in an organized manner. So that's mean turning row numbers, right? Row numbers mean the data into actionable insights. So here the data here, the numbers, for example, 8552, right? So it is scattered here and there. So that it is necessary to organize this data so that we can get some of the insights. Here, this raw data has been presented in table form, right? Table. So that it has been organized in somehow in a meaningful manner. So that is the objective of today's session. What we will master today, first we will understand organizing raw data. Raw data mean unprocessed data. Unprocessed data. Mastering techniques like ordering, right? Ordering, tallying, and stem leaf plot. These are the techniques, basic techniques of organizing raw data. Then understanding presentation. How do we present the data set? Especially we have to talk about differentiating between table form, right? Tabular method and diagrammatic method. There are two ways of presenting data. One is the table form, right? In a table, or we can we can present our data set in the form of charts, in the form of chart. Then strategic selection, knowing when to use table, right? When the use of table is appropriate versus a chart based on the audience. Here, our scope, right? Our scope is limited to only 4 different type of charts. We will discuss pie chart, line chart, column chart, and bar chart. There are 4 based on the audience. Right here, we can see pie chart. This is column chart. This is line chart, right? And construction. Building frequency distribution table for both categorical and numerical data. Already we have discussed what does it mean, categorical data and numerical data. For that, for different purposes, for different type of data, we use different type of charts and tables. Let's see the problem with raw data. So here the raw data, right? The data is been scattered. We just, for example, in the class, we ask a student, what is your marks? Right? We ask the first student, what is your marks? He says 80. Second, 76. Third, 90. Next, 85, 70, 80, 70, 62, 62, 70, 70, 85, 60. Right? The students, they are telling their number. We just note these numbers, just note their data. If we do so, the data look like this. If we just collect the data, then what does it mean? So this is the raw data, right? In the basic form of the data. Right? First student says his marks is 80. The last student says his marks is 85. So based on this, once we collect this data, we couldn't come to any conclusion. So that the next step is to we have to convert this raw data to some other form so that we can understand. So, uh, what is the maximum marks? What is the minimum marks? Uh, then what is the median average marks? Right? How many students pass? How many students fail? So those kind of decision we have to take so that we have to process the data. Let us first define what is raw data. Definition. The raw data is data or information recorded in its original, right? It's in original unorganized form, right? Here we collect data as it is. So it's recorded in its original, unorganized. We didn't organize in the uh, ascending order or descending order. It's been smallest to largest or largest to small. We didn't do that. Unorganized form. So we couldn't write. So it can be found. It can be count how many how many days you attend the class, how many questions you attend in the exam. So that will count how many students in the class, how many papers. Symbols. Sometimes we can use smileys, smiley or symbols, symbols. And the measurement, a measurement like the kilograms, meters square, right? Kilometer, right? It's a temperature, like that. So it can be, right, in any form. The challenge when handling the data, raw data, what are the challenges we can face? The challenge is the main challenge. When the data is scattered, yes, scattered mean the data is goes here and there. We cannot effectively analyze the performance or identify any trends performance if we consider the data we collected representing student marks, mathematics marks. Then how we can analyze how the class performance, which students perform better, and identify trend, right? We want to compare last semester maths marks, and this year max marks. Are there any increasing trend? For example, student X, last year marks, last semester marks, and this semester marks. When we compare this, to compare this, we need data should be in organized manner. If student score are written randomly, right? We, we place them here randomly. It is difficult to understand and class overall performance. So it's very hard to measure the performance. So right. Then structuring the chaos, the classifications. The foundation for meaningful presentation of the data is the classification, the foundation, right? The foundation level, it's a classification. Data classification. Classify mean how we classify data. The basic way is ordering, right? First, we do ordering. And second way, tallying. And third way is stem leaf plot. For classification, we use these kind of uh, techniques. Sometimes we use ordering. So this ordering may possible for numerical numbers, numerical data like 1, 2, 3, count how many males, how many females, right? The counting, uh, right? That is different. The ordering, it's only possible for numerical data like temperature and the kilograms, the height, weight, how many classes attended, this kind of things, right? It's a count. So ascending or descending order, we can order from small value to large value or large value to small value. So that is ordering. So for ordering, we need numerical data. numerical data. Telling so techniques. Telling, no, you might study this mark. The telling here in when you play cricket in your early childhood, 1, right, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So this is the technique for counting. Telling marks a technique for counting the raw data. So counting frequencies. Frequencies mean the number of times, number of occurrences. Stem and leaf diagram. It is for numerical data. So it is easy to present the data in a form, numerical data. Here, for classification, right, it's a classification by attribute. We can classify raw data based on some attributes. Say, gender. How in the class, how many males and how many females? We collect the data. We collect data like this, right? Already we have the data of the student scores, mathematics score in the class. So we can classify them, male and female, right? How many? Then here we can put marks obtained by the male students and marks obtained by the female students. Then we divide, right? We classify male and female. So this is classification, one form of organizing data, right? Earlier, the data is scattered. Now we categorize them. Or first we categorize the classes in students into two, male students, female students, and then we ask the student marks. So that is classification and grade. Then we can ask the students, how many of you are getting A? How many of you are getting B? How many of you are getting C? We can classify, right? So these are the things we can apply. In operation, for business operations here, the sales data can be grouped by year, right? The sales amount in 2020, sales amount 2021, sales 2022, sales 2023, or product. How many Apple brand sold out? How many Samsung brand sold out? Or how many Oppo? How many other brands, Nokia, sold out? Or region, the sales amount by the region, sales amount the Western province, sales amount in Northern province, sales amount in Eastern province, sales amount in Southern province. So these are classifying the data, right? Classification. Let's see the framework for data presentation. Right before that, yeah, right. Here there are two methods of presenting data. One way you can use the table, right? Table method. You can use table method or you can use chart, diagrammatic method, right? So the table mean that the table it's a 2D, two dimension. It has row and column, two-way dimension. Here this is column. This is column A, column B, column C. Here row 1, row 2, row 3, 4, 5. So row. Here you can see row 1, column A data. Here row 2, column B, and row 3, right? This is row 3 and column C, right? So in this way we can put, for example, the marks here, maths. Simply we say the marks, maths, science, and accounting. Right here, student 1, student A, student B, student C, student D. So easily we can place A, he got 80, he got 75, 70, 75. B student get marks say 70, 72, 62, like that. So this is one way of presenting data. So this is a systematic, the table, right? The table method, the systematic arrangement of data in rows and columns, right? It has column and it has rows. Normally in rows we put observations, and column we call them as a field. Second, right, the diagrammatic method. We present the data in the form of diagram. This is a visual representation. Diagram means it's a visual presentation using charts and graphs. Charts and graphs. Here, this is a chart. This is called pie chart. Pie chart. This is a column chart. Column chart. Right. So when we compare this table and the graph mean the chart. The chart works well. The chart works well in presenting data so that the audience can grab the details inside very quickly. But the thing is, we cannot provide whole, right, in details data, in-depth data. Let's see, right, the decision time. When we use table, when we use diagram. In the table, the purpose, right? When we look at the purpose, when we can use the table, you need to exact values or detailed information. When you need, right? When you need to provide the detailed information, detailed data, or the exact value, you can use the table. The user of the table are researchers and teachers. So when they perform right, the deep analysis, when they require the deep analysis, they can prefer table, because table give very detailed information, very detailed data. When we use diagram, right, diagram, who is diagram? When we can use, you need to highlight trend or comparison. You don't want in detail, right? You just wanted to understand what's the trend, right? Here, this is a trend, and we can do comparison, right? For comparison or trend or both, so that you can use diagrams. Diagrams, when it's prefer general audience, right? When you look at the election results, normally they present but the graph, each party, how many votes they are getting, or the percentage, the proportion of votes they are obtained. So general audience, they are not researchers. The context, the quick understanding, everybody understand very quickly, right? So that the table versus diagram. Table provide in detailed data. It's may useful for researchers and teachers and the expert in the analysis. And the diagram we use when we just to show up them comparison or trends or something like that. It's uh, specifically for uh, general audience. Right. Now let's move to deep dive on the frequency distribution table. Frequency mean, what do you mean? It's the count, right? Count or times, number of times instances, sometimes instances occurred. How many a particular event, how many times it's occurred, how many instances occurred, how many times it's happened, distribution. So we present this count in a proper table form. So that is a frequency distribution table. Frequency, when we define what does it mean frequency, frequency mean the number of times a value or category occurs in a data set. It's a simple definition. What does it mean? Frequency. The number of times. This is very important. Number of times a value or category occurs in a data set. Frequency distribution, right? Frequency distribution is just the table we present, right? That we present each items in a table. Frequency distribution, a table, right? It's a table organizing data into values or categories with their corresponding frequencies. Say male, how many times? Male, female, male 20, female 25. So, right? Male how many? 20. Female how many? 25. This is frequency. We present the frequency in a table of form with categories or numbers. It's called frequency distribution. There are steps. There are steps to prepare this frequency distribution table. First, prepare. Second, do the tally marks, and we count the tally mark and then verify. Prepare mean create a table with columns, right? Here, it's a table. So this is a column, right? Column. For example, the group and count, or tally. Sometimes tally and count and total, right? In that way, create a table with column. So the record tally means record marks for each observation. This is the mark 1, 2, 3, 4, 5, 6, 7, 8. So when how we count it? 5, 3 plus 8. Record marks for each observation. It's called tally mark. This mark is called tally mark. Then we count some tallies to get frequencies, right? Here we put the tally mark and we count. How many? 8. So that is count. And finally, the total count match data set. That the data set. That is the thing. This is how is the steps of preparing frequency distribution. The case study had example working with categorical data. Categorical data, you know that. You know what is categorical data, what is numerical data. Scenario, the case, a social worker collect material status of data for 24 women. The key data, the data key means here you can see here M, S, D. Here M denotes married woman. S, here S denotes single woman, not yet got married. Widow, he lost his husband, this widow, right? This one. And D, divorced, right? Divorced. So there are 25 women. Here we count how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Only 24 is here. So altogether, we assume is yes. I put the different color. I use yes. Right? Yes. So altogether, there are 25. Since these are labels, label mean it's a categorical. The M mean is a label. M represent merit. Numerical ordering does not apply. We cannot order, right? First M, right? So we can't give any values for merit or a single or widow or divorce. For example, male, female, we just do count how many males, how many females. We cannot say male is first and female second. We can't say. Red comes first. We can't order the colors. We have already discussed what is categorical data. We just classify the names. Kamal, the name Kamal is better than Kumar. We cannot say, but we can assess in other form based on the marks, based on the score. We can order in that way, but name itself has no any numerical values. Likewise, here these are the labels. Your name Kumar is a label. Kamal is a name. Is a label. Red is a label. Green is a label. Male is a label. Female is a label. So since these are label, numerical ordering does not apply. Right? We can't apply numerical order. So we treat each category separately. Here there are four categories. What are those? Here the category, we can have category, and we need to count, right? So what are the categories we have? Merit, single, and widow, and diverse. There are four categories, and we need to count. So we need to telemark, right? Then frequency count. The count mean count. That is called what? Frequency. And if we need, we can put percentage, right? So we can prepare a table. Telemark, let us count. Here we do the counting. Here first, right, M, we cut M1, we use red color. We use M, we cut here, we count M, and S. Here S, we have S1. And next D, here D1, and W1, D, here S, M, S, D, S. Here already we have 4. So now it occurs fifth. Then simply we cut like this. So it's mean 5. Fifth value, we just cross it. M, already 5. So we could M, right? M. We have to place it space. M, W, M, D, S, W, S, M, D, S. Right, now it's easy, right? Now we find the frequency. M, here 5, 6, 7, 8. Yes, 5, 6, 7, 8, 9. Widow, just 1, 2, 3. And divorce 5. We can find easily. So that we know that total 25. We have to verify, right? First step is we just categorize, we prepare the table, and we put category, and we put the telemark, and third we count the telemarks, and we have to take the total, and then we can verify that. Right, 8 plus 9, 17, 3, 20, 25. Right, here the sum of frequency, right, 25. So it's confirmed, right? There are 25 and we have all the count equal 25. It's called n, right? Now, if you want to need a percentage, if we need percentage, what we do is total 25, right? Total 25. Out of 25, how many males? 8 into 100 is together 36. Likewise, 9, 25. So it should be 32, right? 32 into 100 equal 32%. And 3 out of 25 into 100 and 5 out of 25 into 100, right? So that we can fill the table. So this table is called frequency distribution. Sometimes we don't want this. This is not necessary. This is not necessary. If you need, you can put but the proportion, of male, but the proportion of married, proportion of single, proportion of widow, proportion of divorced, so that we can prepare table. So this category, this and this, very important. Right? Sometimes you can ignore. Sometimes, right? If for the first time, yeah, if first time you are going to count the data, you have to use telemark or other techniques, say stem and leaf plot. So you can use, but for this kind of basic data, the use of telemarks may be appropriate. Any questions here? Any questions? Right here, we put this here. Here we made some small mistake. It has some error, right? It has some error. But the error here 1, 2, 3, 4, 5, 6. Right? No, it should be only we have to use telemark like this 1, 2, 3, 4, 5, not 6, right? Here also same problem, and here also same problem. So additionally, they put one, we have to cut this, right? And here also we have to cut. Then 5, 6, 9. So the proportion of male, proportion of married 32, proportion of single 36, and proportion of divorced 20%, proportion of widow is 12%, altogether 20. And if you put in percentage, it should be 100, the total, right? If you want to find the proportion, you can use a percentage, frequency over number. This is the frequency. This is total frequency. This is called N. This is F. So that you can do the thing. Right. Let's see. Let us discuss this case. Earlier, we talked about the categorical data. Now we work with numerical data, numbers. Right. Earlier, married, single, widow, divorced, in this categorical. Now we talk about the score scenario, the test score, the exam marks obtained by 20 students. The challenge is we just mark here 1, 2, 3, 4, 1, 2, 3, 4, 5. There are 20 marks here. And it is not organized, right? There are 20 students. We randomly ask, what is your marks? 80. Then what is your marks? 76. And what is your marks? 90. Like that, we have collected the data from 20 students. Yeah. Unlike labels, numerical data usually requires sorting or grouping, right? Sorting means ascending order or descending order. Ascending order means we arrange the numbers from small value to large value. And descending order, other vice versa, like this largest value to smallest value. So that is descending order. So if we have numerical data, first thing we have to do is we have to arrange the data in ascending order or ascending order. Here, if you have just 20, it's very easy, right? You can do it quickly. But that's a technique. That's a technique to arrange this data in an order, numerical order. Numerical data can be in order. We can order the numerical data in the form of ascending order and descending order. So that the technique, the technique is stem and leaf plot. Stem and leaf plot. Stem and leaf plot, you know that. So there's a plant. This is a plant, and this is the stem. We can see a leaf. You can see leaf. This is called what? Stem and leaf diagram. Here, you might study in your school days. This is a basic. Here, the bridging the data chaos and the structured table. Here, this label right here, this is not arranged in a proper manner. So we use this technique. For example, to use to use this to place to arrange the data 76, we can take here 76. So the 7 is called stem. This is leading digit. This 6 is a leaf. So trailing digit, right? Trailing digit. Say 86. How we can put here 8, here 6. 72, here 7, just we put 2. And 77, already 7 here, and you can put 7. And 52, we can put here, so that we can write 5 here too. So better to write above 7, the 5, right? There. So there should be an order here as order, or also here you have to maintain order. The benefit, what's the benefit is, we can systematically organize values while preserving the actual data, right? Let's see. Let's see. Here we order the data, right? When we look at the data set, it's like this, right? First instant 80, first 76, then 90, 85, 80, like that. You can see here the data set, right? You can see the data set here. Let's see, right, how we can order them, right? Then for that, I can get the data set here, right? Uh, yes. So this is a data set. When we observe the data set, we can see here, this is 80s, this is 70s, 90s, 80s now. So the maximum, right, the maximum value here, 90s, and the minimum value is here, right, 60s, right? So that we can prepare the table, the scattered stem and leaf. First, we have to find what is largest number, what is the lowest number, right? From this, you can see this is stem and the leaf. This is stem and this is leaf. So what is the smallest number? 60 or 6 series, right? 6, 7, 8, 9, right? So we could write in this way, right? First letter 80, right? Here we put 80. Second 76, 7, 6, 90, 85, 80, right? So what we can do is, first we draw on this 85, 80 and 70, 60, 62, 70, 85, 65, 60, 63, 74, 75, 76, 76, 70, 70, 80, 85, right? So, right, we can write like this, but it's better if you write them in an order like this, right? We write like this, stem and leaf. 60, no? 60, 70, 80, 90s. Here first we should collect the data, the order, right? 0, 0, right? We put 0, right? 0, 0. Next 2. Next 3. Next 5. Right here 0, 0, 0, 0. And then 4, 4, 5, 5, 6, and 6. And here 0, 0, 0, 5, 5, 5, and 90. Right? So that we can order this number. How we can order 60, 60, 62, 63, 65, 70, 70, 70, 70, 74, 74, right? 75, 76, 76, 80, 80, 80, 85, 85, right? 85 and 90. So how many counts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So it's very easy to arrange the number in a ascending order. If you want to arrange in descending order, you can start from the reverse. So like 90 and then here 85, 85, 85, 80, 80, 80, 80, and then here this way 76, 76, 75, 74. In that way you can do. And right, another way, what we can do is you can easily prepare the distribution table, right? The frequency distribution table. How you can prepare this table? Here the number, you can see the number and tally, or you can just without, you don't want here tally mark, you don't want to count, it's easy to count, so that you can put directly count mean what? frequency. So what you can do is here, numbers, what are the numbers? 6, 7, 8, 9. 6, 60s, right? 60s, 70s, 80s, and 90s. You can classify, right? This is a kind of classification, right? Or you can write 62, 69, 72, 79, 82, 89, 92, 99. You can classify, you can group, right? And you can count. How many? Count here. 1, 2, 3, 4, 5. Here 70. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1. Here 5, 13, 19, 20. Easy, right? That's all, right? And also, right, this stem and leaf diagram sometime work as uh, kind of chart. You see, when we look at this, right, you see the range, right? This the length of this leaf is this. So length of 70 is this. It looks like a bar chart, right? It's like a bar chart. Notice how the length of the row act like a bar chart. So you see here, it's a bar. This is the bar. This is the bar, and this is the bar. So when we look at this stem leaf diagram, it's automatically shows us. It's explicitly we can understand the 70s. The 70s got highest, right? Followed by 80s. After that, 60s and 90s. The numbers. So it's stem and leaf diagram looks like a what do you call it? It's a bar chart. See this, the final frequency distribution. So using the stem and leaf diagram plot method 2 allowed us to group the data before the counting, right? We group the data. How we group the data? 62, 69, and 72, 79, like that. Counting directly from the row list method 1 is prone to error. So sometime if we do like this, counting test 1, 2, 3, 4, then sometime it's maybe got errors. It's not like this, this way, right? So 1, 2, 3, 4, 5, like this, right? It may got errors sometimes. Here, what we studied today, first, organize data, right? Organize first. Raw data is useful until it's processed. Useless, right? Raw data is useless until processed. So once you get the data, raw data, the first task we have to do is organize them. Organize the data. Second, classification. Group by characteristics like gender, region, or the scores, like A plus, like that. Or you can classify them 60 to 69, and 70 to 79, 80 to 89, like that. It's kind of grouping, right? Like male and female, you can group the numbers as well. Choose wisely, right? You have to choose the table very appropriately. Yeah, first, table for precision, right? If you want precision of the data, right? In detailed, correct figure, you can use the table or you can use the diagram. The useful tools for organizing the data set. First, tally, right? Tally for categories, tally mark. You can use telemark for, say, for example, to count how many males. You just put 1, 2, 3, 4, 5. It's a count, telemark. Stem and leaf diagram. Stem and leaf for numbers. Let's say marks, right? So that we can use. So this is today session. If you have any doubt, you can ask. Any doubt? Any questions? Any questions?